Now come to 29. A charged particle of mass m and having charge q is held at a distance d from the fixed charge q. If the particle is released, the speed of the particle when it is at a distance 2d from fixed charge is. Now 29. A charged particle of mass m having the charge q is held at a distance d from a fixed charge. So fixed charge is q. This is point charge small q at a distance d fixed, and if the particle is released, the speed of the particle when at a distance 2d from a fixed charge is. Clear? Now this is fixed. Now this charge is released. Then what happened? Due to repulsive force, it moves. They are asking at 2d distance what would be the velocity. Again, very simple. If we follow the law of conservation of energy, we will get the answer. Difference in potential into charge equal to kinetic energy. Whatever maybe, we will get same answer. So initially they have only potential energy. So 1 by 4 pi epsilon naught q by d. Clear? They fixed. So initially this particle has no velocity, it is at rest. So no kinetic energy is equal. Here it has kinetic energy. So half m v square plus potential energy at this point 1 by 4 pi epsilon naught q by 2d. Now half m v square make it subject to 1 by 4 pi epsilon naught common. This comes to this side. Capital Q small q by d is common. 1 minus 1 by 2. So half m v square 1 by 1 minus 1 by 2 is 1 by 2. So this is q by 1 minus 1 by 2, 1 by 2, 2 into 4, 8 pi epsilon d. So make it v subject to 2 goes this side, 2q by 8 pi epsilon naught d m. Clear? If this cancel, this is under root, this will be under root of q by 4 pi epsilon naught d m. They are asking 1 by 4 pi epsilon naught k, and this will be under root of k into q by d m. Clear? Option A is correct. Now come to 30. A charged particle q is shot towards another charged particle q naught with a fixed, which is fixed with a speed v from a large distance. It approaches q up to a closest distance x, and the returns. If q were given a speed 2v, the closest distance approach would be. Here it is. It's not small q. It is only small q. A charged particle q is shot towards a charged particle q naught, which is fixed. So q naught is fixed. A q charge is shot. So means it is projected towards this with a velocity large, with the speed v. If it approaches small q naught, closest distance x, then return. Then it comes due to kinetic energy, it comes to this point, near point at a distance x. It stops. Clear? Let us say initial velocity u, its final velocity will become 0. Or if we take it v initial is equal to v final 0, then due to repulsive force again it moves back. Clear? Means here its kinetic energy is balanced with the total kinetic energy balanced with the potential energy. Clear? So here the potential energy of the two charged particles is U is equal to 1 by 4 pi epsilon naught Q naught Q by X. Clear? Understand? Now this is balanced with half m v square. Next case, what happened? The same charge particle is projected with 2v. Now if this is projected with 2v, what would be the closest approach they asked? Clear? Then second case, same energy equation we will write 1 by 4 pi epsilon naught Q naught Q by closest approach. Let us say it is coming with 2v. Let us say this u we take it as y. Y they are asking. So y half m 2v square. Clear? So using these equations we will make it simple equation. V square is inversely proportional to 1 by x, or it is inversely proportional to distance. So this we can write v1 square by v2 square is equal to d2 by d1. So v1 you take it as v, v2 you take it as 2v, clear, is equal to under root of d2 is asked question we taken as y, d1 is x, or if you make it the squares then no problem. To avoid the confusion, keep it as this square and square. This is v square by 4v square y by x. V square cancel. Y is equal to x by 4. So option is 4. Fourth option is correct. And now 31. A charged particle of mass m and having the charge q is attached to one end of a string of length L. The other end of the string is attached to the point O. The whole system lies on a smooth surface initially. The mass is at rest. A uniform electric field is directed towards the right. The tension in the string when it rotates by 90 degrees. Now question number 31. This is point O. Here they fixed point O, Q, point charge Q comma M, and the electric field applied. Let us say like this in this direction. They are asking uniform electric, the tension in the string where it is rotated by 90 degrees. Let us say it's rotated like this. Clear? Length L. They are asking tension. Tension is always acts towards the rigid support T. They are the T. Clear? Now it is in circular motion. It experiences centripetal force. Who provides this charge Q? Electric field is E. Electric force provides centripetal force. So at this point, let us say velocity is v. Clear? Now force, electric force F is equal to EQ. So EQ minus T is equal to mv square by, what is the distance? What is the radius or what is the length? L. So mv square by L. Clear? Now we need to find the tension T. Clear? Then they ask the T. Now come to this point. Here it experiences electric force. Electric force provides the centripetal force. Or we will follow another method. Change in potential energy is equal to kinetic energy, or work done is equal to kinetic energy. So what is the work done to move a charge here to here? What is the force acting? EQ. Clear, force is EQ. What is the displacement? This is the initial and this is the final. Initial to final, what is the displacement? L. This is equal to half m v square. Clear? So make it a mv square subject. Mv square is equal to 2eql. Clear? Now this value substitute here. This equation substitute this. EQ minus T is equal to mv square is what? 2eql by L. Okay, 1 L cancel. So EQ minus 2EQ is equal to T. Now here we missed one concept here. Here work done is negative, is here minus, here it is minus, here it is minus, this will become plus. T is equal to 3EQ. T tension is equal to 3EQ. Why work done is negative? We are moving in a decreasing field. So we are moving in the direction of field. Clear? That's what work done. We will take negative. Then this kinetic energy substitute in the first expression, we will get the tension. Next, 32. Now 32. Two blocks having charge Q and 2Q are connected by a massless spring of force constant K. They are placed over a smooth horizontal surface. They are released when the spring is in its natural length L. The maximum extension in L when value of Q. It is also simple if you follow the law of conservation of energy. So they fix like this. L, Q, and this is 2Q. So initially they fixed. So which energy is, spring is at natural length, so no energy stored in the spring. Now these two will have, in these two only electrostatic potential energy stored. So initial energy, or U is equal to 1 by 4 pi epsilon naught 2Q square by L. Due to repulsive force, what will happen? Spring will elongate, finally it reaches to extra extension will be L now. L is the extension Q and 2Q, then separation will become 2L. Here what is the energy? U final. We have two energies, one is electrostatic energy 1 by 4 pi epsilon naught 2Q square by, then initially L, spring extended L, so total separation will be 2L plus, what is the energy stored in a spring? Half K x square actually, you are studying first PU, here extension is L, so L square, equate these two, this initial, this is final, equate these two expressions, make it Q square subject to, you will get the answer. Clear? Now 33. There is a uniform electric field of 50 volt per meter between parallel plates as shown in figure. A charged ball is in equilibrium if the mass of the ball is 80 gram. It has excess of electrons equal to 10 power 20, excess of electrons equal to 10 power 20, excess of electrons equal to 10 power 20, shortage of electrons equal to 10 power 16. Field directed towards like this, electric field. So this value is given, E is equal to 50 volt per meter, and a body is in equilibrium. A charged ball is in equilibrium if the mass of the ball m is equal to 80 gram. They are asking number of electrons. This is balanced. Reason, weight act downwards, electrostatic force act upwards. This is EQ. So electric field directed downwards means this is positive, this is negative. So according to question, charged ball is in equilibrium means net force is 0. Already gravity acting downwards. To balance this, another force acts to upwards. Clear? This is positive side. Q must be negative because positive attracts negative. Clear? Q must be negative here. So these two balanced. EQ is equal to mg. Q according to quantization, Q is equal to Ne. So this we can write Ne is equal to mg. Make it n subject to mg by E. Mass is what? 80 into 10 power minus 3 kg. This is given in grams. G, if you take it 10, E is given as 50. Charge of electron 1.6 into 10 power minus 90. Clear? 100 cancel. This comes up 8 into 10, 10 goes minus 2, 10 power 19 by 5 into 16, 8, cancel. This is 10 power plus 17 electrons. So what do we say? 10 power 17, they given 18. Shortage of excess, check it. Now we got 10 power 17 electrons. Clear? Now, but in the options they did not mention. Okay, I will check it. In the next video, I will clarify this answer. Calculation is correct, but probably option power may given wrong. Okay, we will see in the next video. Clear?